Problem 7.2.6. Use the step-by-step method to find I sub 0. We talked about 6 different steps in our class, so we're going to follow those steps. Step number 1, we're going to write the equation, the formula for Vc of t equals Vc of infinity plus Vc of 0 plus minus Vc of infinity and e to the power of negative t over tau. Similar way, they want us to find I sub 0 of t. So I sub 0 infinity plus I sub 0 0 plus minus I sub 0 infinity e to the negative t over tau. Step number 2, we need to find the circuit for t equals to 0 minus. When t equals to 0, we're going to close that switch. So right before that, we're going to get this circuit. So we want to do KVL. Then we have negative 6 plus resistors 3K plus 6K plus 9K. They're series. Therefore, 18K times I sub 0, 0 minus plus 24 equals to 0. Then 18K I sub 0, 0 minus equals negative 18. And I sub 0, 0 minus is going to be negative 1 milliamp. Using this I sub 0, 0 minus to find the V sub C of 0 minus. Then we're going to do KVL, including V sub C, 0 minus. Then KVL, negative 6 plus 3K times I sub 0, 0 minus, negative 1. And then plus V sub 0, 0 minus equals to 0. Now we have negative 6, negative 3 plus V sub C 0 minus equals to 0. V sub C 0 minus is now 9 volts. Step number 3, for t equals to 0 plus, and V sub C 0 plus is going to be the same as 0 minus 9 volts. However, we need to check for I sub 0 minus, right? So we're going to use this V sub C of 0 plus to find the I sub 0 plus. Then if you draw the circuit, it looks like this. So we're going to place 0 plus for the capacitor into voltage source, and then we need to figure it out I sub 0, 0 plus. And switch is closed because this is right after time equals to 0, so switch is closed at time t equals to 0. That'll give us this short circuit here. Left side of the circuit is going to go in that, and then right side of the circuit is going to go in that. Therefore, if we look at this portion of the circuit, we have 9 volts and then one resistor 6K is right there and nothing else. Therefore, I sub 0, 0 plus is going to be V over R 9 over 6K, and that is 3 over 2 milliamp. Hey, Dr. Kim, what happened to the left side or right hand side? They have their own current going through it. Right hand side in the red dotted line, and the current this guy is going to be 24 over 9 milliamp, right? And then similar thing is going to happen on the left hand side. Our focus is to I sub 0, 0 plus, so you don't have to worry about any other portion. We have I sub 0, 0 plus. Now we have 3 over 2 milliamp. Step number 4, for t equals 5 times of tau. So basically, after long period of time, the circuit looks like this. We need to find I sub 0 infinity and V sub C infinity. So we're gonna do KVL. But this time there is a short circuit because the switch is closed. So we're gonna do this loop. Then negative 6 plus 3k plus 6k times I sub 0 infinity equals to 0. Therefore, 9k I sub 0 infinity equals to 6, and I sub 0 infinity equals to 6 over 9 milliamp. That is 2 over 3 milliamp. And to find the VC of infinity, we do KVL in the first loop so that we can include the V sub C of infinity. Then we have a negative 6 plus 3k I sub 0 infinity 2 over 3 milliamp plus VC of infinity equals to 0. Negative 6, 3 cancel out, k and milli cancel out, plus 2 plus Vc of infinity equals to 0. V of C infinity equal to positive 4. Step number 5. In step number 5, we need to calculate the tau. Tau equals C times RTH. Therefore, we need to find the RTH first. To find the RTH, we need to make a short circuit for voltage source and then open circuit for current source. And you need to place RTH in the exact spot of VC, the capacitor place. And again, we have a short circuit here. Because of this short circuit, we don't have to worry about this guy because 9k is parallel to short circuit 0. That'll give us nothing. Therefore, RTH equals 3k is parallel to 6k. They are not series because we need to look at from RTH, and 3k times 6k over 3k plus 6k, that is 2k. Therefore, the tau equals capacitance is a 200 micro times 2k, that is 0.4. Now we are ready to write the equation. V sub C of t equals V sub C of infinity plus V sub C 0 plus minus V sub C infinity e to the negative t over tau. We have V of C infinity 4 plus Vc 0 9 minus 4 e to the negative t over tau 0.4. Vc of t is 4 plus 5 e to the negative t over 0.4. And I sub 0 t equals I sub 0 infinity 2 over 3 plus I sub 0 plus 3 over 2 minus 2 over 3 e to the negative t over 0.4. I sub 0 t equals 2 over 3 plus, you can have the common denominator for 6, so 9 minus 4 is going to be 5 e to the negative t over 0.4. Voltage is 4 volts. The current, it is milliamps.